All right, welcome to Unit 3, Lesson 7. What do you notice? What do you wonder? This has to do with whether you can do a certain operation and get a certain answer with the equation. So let's take a look at this. For the first one here, x would be 2, but if you remember, you can also square negative 2, because a negative 2 times a negative 2 is 4. On the second one, there's no solution to it. The reason why there's no solution is because if you square a negative number, it's positive, so there's no way to square anything and make it negative. This one here goes back to the old zero product property, where you set each factor equal to 0 when the equation's set equal to 0. So you set the first factor equal to 0, and you set the second factor equal to 0. And then you get x is 2 for this solution, because 2 minus 2 is 0. And then you get x is negative 2. Negative 2 plus 2 is 0. So I guess that's kind of the, why would the first equation and the third equation essentially have the same answers. And the square root is just one answer. X is 2. And that has to do with the shape of the graph. So what do I notice? Well, they're all x's. They all have 4s. Even the third one there, a negative 2 times a positive 2 would be a 4, a negative 4. So that would be part of it. And then they all have x's, like I said. But what do we wonder? Why does the first equation and the third equation have the same solution? All right, if we look here, we have x squared minus 1. That's a parabola that's moved down one space. So see, it's down here a space. And we want to know, when is that equal to 3? So when is the parabola equal to 3? Well, right here at 2 and negative 2. So if you look down, negative 2 and 2, that's when the parabola is equal to 3. Well, that's the same answer, the same equivalent answer as when is the parabola x squared equal to 4? Well, right here and right there it's equal to 4. So you look down here, what makes that true? 2 and negative 2. So 2 and negative 2 is the answer to each one of these. And you can make these equations the same algebraically by adding over 1. And then you get x squared is equal to 4. So really, they're the same basic equation. You just manipulated a so that it was a slightly different parabola. It just shifted down one space, but it still holds the same shape, still holds the same answers of plus or minus 2. But again, the question is right here, x squared, when is the parabola equal to 4? And there's two answers to it, 2 and negative 2. All right, so that's kind of what that's all about. And the mistake here, again, is it has to be 2 and negative 2. So x has to be negative 2 as well, not only just 2 to make the thing true. Okay, we're going to solve this one here. So we have x plus 3. I'm kind of skipping some of this stuff. We're going to solve this. And 4. Now, the thing that we're going to do is, what they're trying to get at here is, you see, if you square something and get 4, it could be plus or minus. So it's a negative squared, right? So some negative number squared would be 4. Some negative number, or some positive number squared would be 4. So plus or minus 4, plus or minus something, it has to be inside the parentheses here. So the convention to solve this would be to take the square root of each side. And we have to consider x plus 3 is equal to 2. But we have to also consider that x plus 3 could be a negative number, and that negative number squared would be positive 4. So there really is two solutions to this. So we're going to subtract the 3 over and get negative 1, subtract 3 over and get negative 5. So those are the two answers to this. Next page. Now we're going to look at squaring each side of the equation. If we square each side of the equation, we don't have to worry about plus or minus because of what's going to happen in this problem here. So they're just saying this is how you solve this. You square each side, you add 1 over it, you get x is 10. So to prove that x is 10, I'm going to put 10 back into the equation. So it's 10 minus 1, take the square root. 10 minus 1 is 9. The square root of 9 is, of course, 3. So 3 is the answer, and that's what came out of it. So that is correct. What they're trying to get at here is the fact that if you square root something, right, and then square roots only produce positive answers. So the square root of a number has to be positive. There's no way for it to be negative. So this here has no solution. So that's what's going on in that problem. Now we're supposed to practice solving these together, and I believe the next page. So that's kind of so we're going to solve each one of these. All right, so here we go. So we're going to focus in on this to solve these. Number 1, first step. Oops. Number 1, first step would be 2. I'm going to copy it down first. Okay, square each side. Why am I squaring each side? Because squaring and square rooting are opposite operations. So then I'm going to get t plus 4 is 9 squared. 3 times 3 is 9. Oh, sorry. 3 squared, which is 9, not 9 squared. My bad. Subtract the 4 over, and you get t is 5. So t is 5 is that one. And it makes sense. If you put 5 back in for t, you would get 9, and then square root of 9 is 3. Okay, 2. Negative 10 is equal to negative square root of a. Well, there's this extra negative here in front, so it's like there's a negative 1 sitting in front. So I'm going to divide by negative 1 first. So that's going to leave it 10 is equal to square root of a. Then we just do the opposite of square rooting, which is squaring each side of the equation. So we get 100 is equal to a. And that we put the 100 back in, that totally makes sense. Okay, number 3. I'm going to erase this so I can do 3. Big eraser, big eraser. So you can probably put yours at the bottom of the paper or whatever. Okay, back to the pen tool, green. Oh, I'll do blue, why not? So 3 is square root of 3 minus w minus 4 is equal to 0. So I'm still want to isolate the radical symbol. So I'm going to add the 4 over. And we get 3 minus w is equal to 4. Then we're going to do the opposite. Opposite of square rooting is to square each side. So then I get 3 minus w is equal to 16. So w has to be a negative number because you have to have minus a negative to make it 16. So w would be negative 13 would make that work. And the last one is really easy. It is, I thought I had do not disturb on. I do have do not disturb on, yet I got a text message from the dentist. Oh well. Number 4 is z, square root of z plus 9 is equal to 0. So I'm going to subtract the 9 over to isolate the radical. Square root of z is equal to negative 9. All right, that is a done deal because I just talked about this. Can you take the square root of something and get negative? No, that's impossible. So there's no solution to this one for z. All right, so here's the summary. Basically, it's just talking about like if you have a basic parabola, if you want the basic parabola to be 4, plus or minus 2 would work. 2 squared is 4, negative 2 squared. Here, if you want it to be 2, you'd have to do plus or minus the square root of 2. But if you have negatives, right, x squared cannot be a negative number because if you square something, it's going to always be positive. So that's the gist of that. Okay, purple page, purple page, purple page. Purple page is 302, 303, and 304. So the purple page is just really spread out. It's 7 questions, kind of like normal, but it's really spread out. Okay, so the first one here, they're talking about, you know, the errors with the plus or minus. Here you're solving each one of these. So you got to solve, you got to isolate the radical. So on A, what are you going to do first? How are you going to get the radical symbol by itself? Well, you're going to subtract over the 7. And then you get the square root of x plus 4 is equal to negative 2. And then there should be an alarm going off in your head. Auga, auga, woo, woo, woo. I wonder if we can search for an alarm. Search. Oops. Get an alarm out here. Keyboard, backspace. Alarm. Search. No results found. I thought you could add things like alarms to this. I don't know. Over here? This button? Nope. I don't remember. There's a way to add stuff to this. I should be able to add an alarm clock. Oh, well. So you can't do this. This would be no solution. Because the square root of something cannot be negative. Next page. Pick all of them that apply here. That one we've talked about. This one here is just looking, you know. So this sentence that you say with this is parabola. When does the parabola equal 3? Right? When does the parabola equal 3? So you go to 3, right? And when does it, right there and there. And then you look down. You look down at the x-axis. That's what x is. X something squared is 3. So that's what's going on. They're trying to connect the graph to the square root. Okay, now on number 7, you have to do long division. 3x plus 5. And then we got 3x cubed plus 11x squared minus 14x minus 40. So you remember how you do this? You go something times 3x is 3x cubed. So we got to have an x squared. And then you multiply. And then you get 3x cubed plus 5x squared. And then you take the red pen and you got to subtract those off and you go from there. So you pick it out, you multiply it out, and you subtract it out, and then you start over again. So you pick out something, you multiply something, and you subtract something, right? So you pick out something, that's the x squared. You multiply it out, that's where I got this here and here, and then you subtract it out. That's why I did the subtracting after I multiplied it. And then you go from there. So then you get 6x squared minus 14x, eraser, erase. And then you pick out the next thing, all right? Pick it out, multiply it out, subtract it out. And I think that's going to be where I stop with this. So give it the old great effort.